In this screencast, we will develop 4 exponent laws of the real number system. There are many more than these 4 exponent laws. However, these are the only 4 that you will be responsible for in this class. The first exponent law involves rewriting expressions of this form, x to the m power times x to the n power. Remember, when they're put together, that means there's a multiplication here that we don't actually write down. So it's x to the m times x to the n. In order to come up with this law, I don't simply want to just tell you what it is. Instead, I want to take a look at an example and see if we can figure out what the law should be. So we want to fill in this side of the equation. So to do this, let's take this example. And what we want to do is first expand x to the fifth times x squared as a product of the bases. So x to the fifth power has a base of x. So x to the fifth power means we've got 5 x's that are being multiplied. But then x to the second has a base of x, so that means we're multiplying with 2 more x's. Now, if we put this back together, how many x's are being multiplied here, i.e., let's put it back in exponential form. And notice you've got 7 x's, so this would be x to the 7th power. So x to the 5th power times x to the 2nd power is equal to x to the 7th power. Now, can you see a pattern here? What can we do with these exponents to get this new exponent? Well, you may notice that x to the 5th times x to the 2, if you were to add the 5 and the 2, you get this new exponent of 7. And that's not only true in this specific example, but it's true in general. So if you have x to the m times x to the n, that's equivalent to x to the m plus n power. So you can write it as one expression rather than these 2 expressions multiplied together. So that is our first exponent law. This expansion over here was just done to try to figure out what the law is. In general, we don't want to have to do that. So for example, if you had x to the 7th times x to the 4th, I don't want to expand the x to the 7th and the x to the 4th and then see how many x's there are. Instead, we want to use this law. When you have exponential forms with the same base and you're multiplying them, you can add the exponents to get the new term. So this is x to the 7 plus 4 is, of course, 11. So x to the 11th is equivalent to x to the 7th times x to the 4th, but I'd much rather see it written like this in the simpler form. Also, please make sure you be aware with this. This only applies with exponential forms with the same base. For example, x to the m times y to the n, there's nothing we could do with that. That expression would not be able to be rewritten because these are not the same base. Let's take a look at another law. For our second exponent law, we want to be able to rewrite expressions of this form. You have x to the m power, and then that whole thing is being raised to the nth power. And again, to figure out what we should have over here, we're going to work by expanding this expression. So you have x to the 5th power, and then that whole thing is being raised to the 2nd power. So first, what is the base of the square? Well, that's this entire x to the 5th. So squaring x to the 5th means you've got 2x to the 5th being multiplied. Now, from here, we could go ahead and use the law that we just established, or you could break it down even further. X to the 5th has a base of x, so that means you're multiplying 5 x's. And then we have another x to the 5th, so that means you have a base of x, so that means you're multiplying by another 5 x's, giving you a total of 10 x's, which would be x to the 10th power. So we expanded this because we want to see if we can come up with a pattern. Let me rewrite what we started with and then what we got for the final answer. So x to the 5th to the 2nd power is the same thing as x to the 10th power. So do you see something you can do in this scenario with the exponents to get the corresponding new exponent? And notice 5 times 2 is exactly 10. That's true in general. If you have x to the m raised to another power, you can multiply these exponents and have just x to the mn power. Again, our objective for doing this work was to see if we could discover what the rule was. Now that we have the rule, we want to be able to use that directly without having to expand first. Let's look at an example. If you had x to the 2nd power and then that thing raised to the 4th power, that would be the same thing as x to the power 2 times the power of 4 gives you a new power of 8. These 2 expressions are exactly the same thing. And as you could imagine, people would rather work with this. You don't want to see 2 exponents if it's not needed. This is the same thing, and it's a simpler thing to work with. So this is our second exponent law. Let's develop another. For our third exponent law, we want to be able to rewrite expressions of this form. It's when you raise a product. Remember, xy is the product of x and y. When you raise a product to a power, see the parentheses around the product? We want to see how we can rewrite this expression. Well, here we've got a product. Remember, 2y is 2 times y, and we're raising it to the third power. So this is an example of this form. And to, again, come up with the rule, we want to expand this. So first, what's the base of this exponential expression? Well, the base is the 2y. So raising 2y to the third power means you're multiplying 2y's. But don't forget, 2y means 2 times y. And even though we've not talked about a bunch of the laws of the real number system, most of you already know you can multiply in any order. So I'll rewrite this like this. And of course, that's 2 times 2 times 2 is 8, and y to the third power is y cubed. So we expanded it and rewrote it back like this in exponential form. So let's look at it, the whole thing. From the beginning, you've got the cube of 2y, and that is the same thing as 8 times y cubed. So the question is, what do you do with this exponent 3 out here? We want to be able to write this expression without having to do all of this expansion. Notice that 8 is 2 to the third power. And then y to the third power, of course, is y to the third power. So essentially what's happening here is each of these factors in here gets raised to the third power. The 2 gets raised to the third power, giving us that, and the y gets raised to the third power, giving us that. Of course, I don't want to leave this expression, though, because 2 to the third power is just a number. Actually do that computation. 2 times 2 times 2 gives you exactly 8. So this is 8y cubed. So in general, if you have a product and raised to a power, the power applies to each of the factors of the product. So if you have the product x times y to the m power, that's the same thing as raising the x to the m power times also raising the y to the m power. That's true in general. Let's try another example like this where we don't have to actually expand it first. We want to go to use the rule directly. So let's take, for example, negative 3, that quantity, negative 3 times x, that quantity raised to the fourth power. Because you've got a product here, and we had a product up here, the x is going to be raised to the nth power, and the y is going to be raised to the nth power, and then you have this new product. So that means this factor of negative 3 is going to be raised to the fourth power, and the x, that other factor, is going to be raised to the fourth power. Now, technically, I purposely just wrote this wrong. Hopefully, you watched the first video in the Exponent Laws series here. Why is what I wrote down incorrect? Take a moment to think about that. And hopefully, using the language again might help you see what's wrong. So in this expression here, we want to raise the negative 3 to the fourth power, and we want to raise the x to the fourth power. We've raised the x to the fourth power, but we have not raised the negative 3 to the fourth power. This is not the fourth power of negative 3. This is the opposite of just 3 to the fourth power. If you want the fourth power of negative 3, you need to have it written like this. And this is absolutely essential because when you put it in your calculator, if you put this into your calculator right here, this is 81. If you put it in without those parentheses there, you would have gotten negative 81, which would be incorrect. So when you want the fourth power of negative 3, we need to make sure we're actually taking the fourth power of negative 3. That needs to be in parentheses. If those parentheses aren't there, then you're taking the opposite of just 3 to the fourth power. And our final answer here is 81 times x to the fourth. Let's develop one more exponent law. With this fourth and final exponent law for us, we learn how to rewrite a power of a fraction. So you're raising a fraction to an exponent of m. So same thing as we did in the previous ones. Let's see if we can figure out how this works. So here we've got a fraction x over y raised to the second power. Let's expand this. Well, what's the base of this exponential form? Well, the whole fraction itself is the base. So that means we're multiplying two of those. So we've got x over y times x over y. And hopefully you recall from your pre-algebra days, you multiply fractions straight across. So this would give you x times x in the top and y times y in the bottom. Now, if you rewrote the numerator and denominator each in exponential form, what would you get? You'd have x squared on the top and y squared on the bottom. So we expanded this here to come up with this. Let's now rewrite it how it originally was, which is the square of the fraction x over y, and our new result is x squared over y squared. Do you see what we can do to go directly from this to this without having to do this expansion in between? Well, hopefully you notice the numerator got raised to the power and the denominator also got raised to the power. and that's true in general. If you have a fraction raised to the mth power, you'd raise the numerator to the mth power, and you'd raise the denominator to the m power as well. Let's take another example and do it without expanding first. So what if you had 5 over y, that thing raised to the third power? How could you rewrite this using this law instead of expanding it first? Well, the law is basically saying that you apply the exponent to the numerator and to the denominator. So we're going to have 5 to the third power, and we're going to have y to the third power in the bottom. And of course, don't leave this as your final answer because you can rewrite 5 to the third power. 5 times 5 times 5 is 125. And of course, we still have over y cubed. So this expression right here is the same thing as this expression based on this rule. Let's now review all 4 of our laws. If you have the product of 2 exponential forms with the same base, that's the same thing as the same base raised to the sum of the exponents. If you got a power raised to another power, you can multiply the exponents, and of course the same base x again. If you have a product raised to a power, you raise each factor to that power, so the x gets raised to the m and the y gets raised to the m. And if you have a fraction raised to a power, you raise the numerator to the power and the denominator to the power. Now those are our 4 laws here, but I want to make sure you're careful with something. The exponent laws only apply to products and quotients. Notice this is a product. This is technically a product because it's an exponent. This is a quotient. This is a product. It does not apply to sums and differences. So it does not apply to sums and differences. So for example, if you came across the cube of x plus y, that's a sum, that is not x cubed plus y cubed. There is a way to rewrite an expression like this, but it's not by using the exponent laws. So make sure you realize the exponent laws only apply to products and quotients, not sums and differences.